Hello everyone and welcome back to the channel. In the world of distributed systems, services are constantly talking to each other. But how they talk is a fundamental design decision with massive implications for your system's performance, scalability, and reliability. This is the core distinction between synchronous communication and asynchronous communication. Mastering this choice is crucial for any system design interview. Today, we are diving into both models and when to choose each. Okay, so first let's talk about the core distinction, like does the sender wait or not? At its heart, the difference between synchronous and asynchronous communication boils down to a simple question, which is, does the sender wait for a response from the receiver before continuing its own task or not? So let's just take an example. In the synchronous communication, we have the client, we have the server. The sender, here the client, will wait for a response from the receiver to say from the server or from the receiver to acknowledge then that the task is being done successfully or the task being failed. So again, the sender will wait for a response from the receiver. Basically, it's a blocking operation. It's like a phone call. You call someone, you wait on the line until they pick up your response, okay? Or maybe you blinked until like the conversation is over. In the asynchronous communication, it's a pretty different. It looks quite the same, but it's really different. The sender will send a message or request and doesn't wait for an immediate response. The server will send a response back to the client, but this response says only one thing, that we received this response, but we don't have the results right now. The results is being done in the background. So it's basically a non-blocking operation. It's like sending a letter or an email. You send it and you immediately go back to whatever you were doing. You will get a response, but later, and you don't wait right away. Okay, this is a fundamental difference in waiting behavior. Waiting behavior drives their respective pros and cons, and we will talk about them more in deep dive. Okay, so let's start with synchronous communication. So let's talk about the mechanism first. Typically, it involves direct API calls, mostly using HTTP and HTTPS, like REST API or RPC frameworks like gRPC. The client makes a request and its execution flow passes until it receives a response from the user. It's a pretty simple. The client, and we have here the server. The client will send a request. It waits, okay, until the server sends a response. That's it. What is the pros and cons of this way of communication? The first thing, we have an immediate feedback, like the sender gets an instant success or failure response. This is essential for workflows where the immediate outcome is required for the next step. Number two, simpler workflow. For short, simple request response workflows, it's often easier to reason about and debug. Number three, strong consistency. It's often easier, okay? Because it's generally easier to maintain strong consistency with synchronous communication calls as a client waits for confirmation. But what are the cons of this one? First, we have tight coupling. Like the sender is directly dependent on the receiver's availability and speed. If the receiver is quite slow or down, the sender is blocked. Number two, blocking, the thing that we ended our first con. So blocking, like the sender's process is blocked here, like consuming resources while waiting. This can hurt responsiveness and overall throughput. Number three, increased latency. The total request time is the sum of all sequential synchronous calls. Number four, scalability bottlenecks. Like a slow downstream service can create a cascading bottlenecks, limiting the scalability of the entire chain. Lastly, we have no spikes handling, like it can't gracefully absorb sudden bursts of work as the downstream service must handle everything immediately. Okay, so what are the use cases for this type of communication? What is the use cases for this type of communication? First, user authentication and login, retrieving data for user interface that must be real-time, immediate payment authorization, where the transaction must succeed before the user process it, okay, or validation of critical parts. Okay. So next we will talk about asynchronous communication. So this involves the producers sending messages to an intermediary with a message queue, and then consumers picking up those messages. Example for that, like message queues, webhooks, event buses, like pub subsystems, things like that. We have the client, we have the server. Let's say that we have multiple servers, or we can say that they are workers, or we can say that they are consumers, whatever you want to say. And here we have the message queue. The client will send an event or a request to the message queue, and one of these servers, S1 and S2, will pick this request or this server and work on it. So this is how it works on high level. What is the pros of this one? The pros of this one, it's loose coupling, because the producers and the consumers, the producers here is the client because it's produce the request, and the consumer here are the servers because it's consume the request. The producers and the consumers are independent. The producer doesn't need to know if the consumer is available or how fast it processes this message. This makes services easier to develop, deploy, and scale independently. Number two, improved responsiveness. The sender doesn't block, it sends the message and immediately responds to the user, improving the user experience for long-running tasks. Scalability and load leveling also, it's one of the pros, because like queues acts as buffer, absorbing sudden traffic spikes. Consumers can process messages at their own pace, and you can easily add more consumers to handle increased load. Also, there is resilience and durability, like message brokers persist messages. If a consumer is temporarily down, messages are stored and delivered once it comes back online, preventing message loss. If a consumer fails mid-processing, the message can often be requeued. And lastly, fault isolation. A failure is one consumer or downstream service doesn't block the producer or the consumer. Okay, it's a great, but what is the cons? The first thing, we have delayed feedback, because the sender doesn't get immediate confirmation for completion for like user-facing tasks. You might need a separate notification mechanism, for example. For things like that. Number two, we have eventual consistency situation. So data might not be immediately consistent across all components because we have a delay. Number three, we have increased complexity, huge in increasing in the complexity, because adding a new component, specifically like adding a message broker to manage, monitor, and troubleshoot, debugging distributed asynchronous flow can be harder, way more harder. It's specifically in the testing. Number four, we have a problem with the idempotency, because consumers must design to be safely handle duplicate messages, as brokers might deliver messages more than one time, but you can handle this with like IDs for each request. It's pretty easy to handle. Typical use cases for this one, you like for sending emails, notifications, image and video processing, report generation, processing large data imports, analytics data collection, background tasks, or initial payments acceptance. Yeah, all of these things. Okay, so when to choose which? In system design review, your choice between synchronous and asynchronous communication is critical and depends entirely on the context. Okay, the context here is king. I would say choose synchronous when operations require immediate user feedback. If the operations require immediate user feedback, are part of blocking workflow where the next step absolutely depends on the current step's success, or demand strong transactional consistency across multiple steps. Also, you could choose not also, otherwise you can choose asynchronous communication when you have long running tasks need to decouple services. Yeah, maybe also you want to handle traffic spikes gracefully. Maybe you want to improve overall system responsiveness or enable complex event-driven architecture. I would say mostly you will use a hybrid approach, like most real-world examples or system use combinations of both. For example, a user placing an order might be a synchronous API call to accept the order, followed by a synchronous message to queue for payment processing, inventory updates, and email notifications. So if you want to know how to discuss it in your systems and reviews, I would say when discussing this, clearly define both models, like always discuss the trade-offs. This is important. You need to discuss the trade-offs all the time. Discuss the trade-offs. Like responsiveness versus immediate confirmation, coupling versus complexity, justify your choice based on the specific requirements of the task. For user login, for example, synchronous is vital for immediate feedback. For sending a welcome email, asynchronous is better for ensure responsiveness and resilience. You need to show awareness of the system for each APIs versus message queue webhooks. So that's it for this video, and see you in the future.